Hello, I'm Emma Roshto and welcome to my presentation on ICUnity. This was a project that was initially developed at the Milan Critical Care Datathon in January, and we're at an early stage of development, so we'd love some further advice and contributions from the community. The last decade has seen a proliferation of electronic health record systems. Some of this data is available publicly, most notably from intensive care units, and it's enabled an increasing amount of work in machine learning. But many of us will be all too familiar with the challenges of working with this kind of data. To put it generously, the quality of the data is variable, so often we have to do a significant amount of pre-processing, which makes testing a single model on two different datasets very difficult. This is something that we'd really like to change, so the central question is, can we automate some of the process of matching across datasets and pre-processing? To mention some specific examples when matching multiple EHR datasets, we can have differences in formats, labeling of the same variable, language barriers, units, similarly named but different measurements, variable types, granularity, and finally variation in the data distributions due to population differences. And a lot of these issues are going to be universal no matter what your research question is. So we've developed a general framework for the integration of data, and we use the AmsterdamUMCdb and MIMIC databases as the main case studies. So the aim was to match distinct concepts as defined by various ontologies to their corresponding variables in each dataset. We've developed a prototype tool which is able to automatically generate likely matches based on parameter naming and similarity in the data distributions. Variable strings in Dutch are first translated into English using the Google Translate API, and then compared to the MIMIC strings using the Levenshtein distance, which is the minimum number of single character edits that you have to make to get a match. So we can see that in some cases, the correct variable is identified, like pH and glucose in green. And when it does match, it's generally accurate, so it has a good specificity. But many variables fail to match, like PT and the prothrombin time, so the string matching has poor sensitivity. We can partially mitigate for this by also considering the data distributions. So we tested some simple methods like t-tests and interquartile range overlap, but we might need to employ some more sophisticated methods to get better specificity. To show some examples of the system in action, this is an example of a correct match based on both string and distribution. And sometimes our prototype provided a useful sanity check. So this is a genuine match for pH, but for some reason the distribution is quite strange in MIMIC. And finally, we developed an interactive tool that can be used by clinicians to verify potential matches. So they can quickly accept or reject matches to generate a harmonized data file with data from both databases. Thank you for listening to my talk, and I'd love to take questions later.